Hello students, welcome back to our channel Diksha Karnataka. So as you all know, we have started a COMEDK mock test series. So mock test 3 has already been released. So in this video, we'll be discussing the solutions of your chemistry mock test 3 solutions. That is part 1, which comprises of question number 1 to question number 30. Okay. So in this video, the first 30 questions will be there. So you have to, I hope all of you have downloaded the question paper, solved the paper, and then you have to come here to check the solutions. Okay, if you have not yet downloaded the question paper is available in our WhatsApp channel, and the link of the WhatsApp channel will be there in the description section. So please go download the question paper, solve once by your own, and then come back to see the solutions. Okay, so let us start with the first question here. Monomer of monomer of the compound given is methyl, and again we have methyl, and we have here COOH. Okay, so once you see this, you might think this question comes from polymer or something, but in hydrocarbons also there is a polymerization reaction. So if you see this one, 2-methyl propene, okay, so we have this one, 2-methyl propene. So when this compound undergoes polymerization, we get the given compound. Okay, so the correct answer for this question is option number A. Now you can see easily that there should be some similarity between that compound and this compound. So this is we have 2-methyl propene, one branching is present. So easily we can guess this answer. Now coming to the next question. Which of the following reagents will convert CH2Cl into CH3CH2COH? Okay, so acyl chlorides to aldehydes, we know that is your H2 palladium barium sulfate. Correct answer is option number C. Now next question, the energy of an electron in an atomic orbital of a multi-electron atom depends on. So energy depends on N and L, that is your principal quantum number and azimuthal quantum number. So correct answer is option number B. Many of you might have written only principal quantum number, but the energy depends on both. Okay, you can see here, if we know 2s and 2p, when you fill the orbitals, right, 1s and then we have 1s orbital, then we have 2s and then 2p. So here both are having the n value is 2, but still 2p is more than 2s, right? So that is why that depends on both your n and l value. Next question. A deep brown gas is formed by mixing two colorless gases. The two colorless gases are, so when you add NO plus NO2, we get NO2, which is a deep brown. So the correct answer for this question is option number B. Next, an organic compound A on treatment with NH3 gives B. Okay, so first write down here, organic compound A on treatment with NH3 gives B. Now, which on heating gives you C? So on heating we are getting C. Then C is treated with Br2 in presence of KOH. Okay, so when it is treated with Br2 and KOH, we get the compound ethylamine. Okay, now if you see this Br2 KOH is nothing but your Hofmann bromamide degradation, right? Now that means the number of carbons must have decreased. If in the product we are having 2 carbons, so reactant must have 3 carbon. Now if you see here there is 2 carbon, we can eliminate. Here there are 4 carbons, right? We need 3 carbons, so we can eliminate this one. Here also 4 carbons are there. Here if you see, it is 3 carbon. So the correct answer should be option number D. But we can check the reactions also. So when we treat with this one, CH3CH2 COOH with NH3, so it is a base, this is an acid, so it forms COO minus and NH4 plus. Okay, now when you heat it, we get the amide, so this is our A. Now when we heat this, we get the amide product, that is CH3 CH2 C double bond O NH2. Okay, so this is your B. Now when you treat it, so this is already A is given, so one second, this product formed is B. Okay, and then after heating, which one we get? That is your C, right? Now on C, if we do Hofmann bromamide degradation, okay, on C when you do Hofmann bromamide degradation, we get D. Okay, or that is your ethylamine. So correct answer for this question will be option number D. Next one, in the electrolysis of which solution OH minus are discharged in preference of Cl minus ions? So that means in which case we will get OH minus will be oxidize in present instead of Cl minus. So that is when you have very dilute solution of NaCl, right? So we have here Na plus and Cl minus, H plus and OH minus. So when the solution is very dilute, OH minus will get discharged. So correct answer is option number B. Okay. Next one. Glycogen is a branch chain polymer of alpha D glucose units in which the chain is formed from C1-C4 and C1-C6 linkage. Its structure is similar to. So this is very easy question. You know, in starch there are two parts. One is amylose and amylopectin. In amylopectin also there is C1-C4 linear chain and branching is there at C1-C6. So the extensive network of amylopectin is nothing but your glycogen. So it is similar to amylopectin. Correct answer is option number B. Okay. Next question, how many Faradays are required to liberate 8 gram of hydrogen gas? So if you write the hydrogen reaction, right, this is the reaction. So I can say for this is 1 gram. So for 1 gram, I need 1 Faraday or 1 mole of electrons. So for 8 grams, we will require 8 Faraday. Correct answer will be option number C. Next one, the complex which has the highest magnetic moment among the following. So for highest magnetic moment, we need unpaired electrons, right? The more is the number of unpaired electrons, more will be the magnetic moment. You know the formula for this one? The magnetic moment is equal to root over of n into n plus 2, where n is the number of unpaired electrons. Okay. Now if you see here, we'll start with, if you see these all are, so basically the idea should be it should have a weak field ligand, then there will be no pairing of electrons and then there will be unpaired electrons left. So if you see COF6 3 minus, cobalt is in plus 3 oxidation state, so that is your 4s 3d6, right, 4s2 3d7, so 3 electrons will be removed, so 3d6. Now if I want to fill 3d6 here, so 1, 2, 3, 4, 5 and 6. So number of unpaired electrons here is 4. Okay. So now you can check the other options also. Here it will be maximum. So the magnetic moment will be maximum in option number A. Now let us see the next question. Chlorobenzene can be prepared by reacting aniline with. So we know we have aniline. This can be converted to your N2 plus and Cl minus, right? And then if you treat it with cuprous chloride, then we will get chlorobenzene, right? So this is your benzene disonium chloride. So NaNO2HCl, that is the first one here, NaNO2HCl, and then with cuprous chloride. So correct answer is option number D. Okay. Next question, what fraction of a reactant remains after 40 minutes if T half is 20 minutes for a first order reaction? So fraction, so let us start with the fraction 1. Okay, if the initial value is 1, then after first half-life, that is 20 minutes, it will become 1 by 2, and then another half-life, that is 20 minutes, it will become 1 by 4. So how much will be remaining? 1 by 4. Correct answer is option number A. Okay. Since it is already given that it is a first order reaction, so the half-life does not depend on the initial concentration. Next question, propene can be converted to 1-propanol by oxidation. Indicate which set of rearrangement can be which set of rearrangement among the following is ideal to do the above conversion. Okay, so we need propene to propanol. So we have this one, propene to propanol. Now if you see here, there is anti-Markovnikov addition has taken place. So that happens in presence of B2H6 and alkaline H2O2, that is hydroboration oxidation. So correct answer for this question will be option number C. Now next one, select the correct statement or expression about the graph. So there is a pressure volume graph. You can see the pressure is decreasing. Okay, so sorry, the volume has decreased from BF to Vi. So that is an compression, right? So it is an irreversible compression. This statement is correct. Now you can see the pressure value is also not constant. It is changing continuously. So pressure is not constant and changes in finite steps during the compression from initial volume to final volume. Right? Both the statements are correct. So correct answer for this question will be option number C. Next one. The end product C in the following sequence of chemical reaction is. So first of all, when you treat acid with a base, we will get CH3COO whole 2 Ca. Okay. Now when you heat it, we will get acetone. Okay. So this is your acetone will be formed. That is option number, this is A and this is B, right? So here this structure you can see like this, it is CH3, C double bond O, Ca, O, CO, and then CH3. Okay. So now what happens? This one will give you acetone after breakage, after you heat it. Now if you treat it with NH2OH, that is your addition of ammonia derivative, right? So here what happens? Water gets eliminated, right? So this H2O will come out. Now what I will be left with? CH3, C double bond, NOH, and then CH3. Right? So this is nothing but your acetooxide. Correct answer is option number D. Okay. Now let us see the next question. Why is HCl not used to make the medium acidic in the oxidation reactions of KMnO4 in acidic medium? So if you use HCl, okay, and you use KMnO4. So KMnO4 is a very good oxidizing agent. It converts Cl minus to Cl2. It oxidizes Cl minus. Okay. So that is why we cannot use HCl. So a KMnO4 oxidizes HCl into Cl2, which is also oxidizing agent. So correct answer for this question is option number B. Next, increasing pKb values of ortho, meta and para toluidines are. So this question is important one. Ortho, para and meta toluidines. So we have this one as ortho toluidine. Then we have NH2. We have meta toluidine. And then we have paratoluidine. Okay. Now what happens here? We have to understand their basic property. Basicity is like we can explain the tendency to accept the hydrogen, right? So once what happens in orthotoluidine, once this one accepts one H plus, it will form this one. We will get NH4 plus and then CH3. Okay. So what happens here, due to the repulsion, okay, due to the repulsion or due to the steric hindrance, the NH4 plus present goes out of the plane. Now once it goes out of the plane, it cannot be stabilized by the resonance. Okay. So that is why this one will be the least one. Okay. So the basicity order, if you check, the basicity order of ortho will be the minimum one. Now if you check meta and para, so meta has your, you can say, plus I effect, and para has your plus I and plus M effect, right? So because it is having plus M, sorry, hyperconjugation effect. Okay, it has hyperconjugation effect. So because it has hyperconjugation effect also, it can stabilize better. So it will be most basic and then meta and then para. So basicity order is this one. So pKb will be opposite to that one. So ortho, meta and para. Okay. So we have this one. Let us see, ortho, meta and para. Correct answer is option number A. So let us see the next question. When a catalyst increases the rate of a chemical reaction, the rate constant. So if you have seen, K is equal to A into e to the power of EA by RT, right? So when catalyst is used, activation energy will decrease. So if activation energy is decreasing, this whole fraction will decrease. E to the power of that fraction will decrease and K will increase. Okay. So the correct answer for this question will be option number B, that is increases. Okay. Rate constant increases. Now next question, graphite is a good conductor of electricity due to the presence of free valence electrons, right? So there is a carbon, there is no lone pairs, there is no cations and anions, the valence electrons are free, so they can conduct electricity. Next, what is the free energy value for the half cell reaction? Li plus electron is giving you Li and these values are given. Okay, so now we can calculate. This formula is very simple one, direct formula. Delta G is equal to minus NF E naught of the cell, right? Now if you see, minus N value is 1, F value is 96500, okay, and then E naught cell is minus 3, right? So if you solve this, we'll get 289.5, this much joules, right? Now if you want to convert it into kilojoules, we'll get 289.5. So the correct answer for this question will be option number A. Next, which of the following does not exist as a Zwitter ion? So there are para-amino benzoic acid. If you see, para-amino benzoic acid. Okay. Now what happens here? The lone pair of the nitrogen is involved in resonance, right? So it has, this lone pair is not available to accept this H plus, right? So that is why it does not exist in the form of Zwitter ion. So correct answer for this question will be option number D. Next one, the half-life of a first order reaction is 30 minutes and the initial concentration of the reactant is 0.1 molar. If the initial concentration of the reactant is double, then the half-life of the reaction will be. Okay, so let us see the question. The half-life of the reaction does not depend on the initial concentration, right, for a first order reaction. So if initially the half-life was 30 minutes, now also the half-life will be 30 minutes, but the options are in seconds, so you can convert it into seconds. So we will get 1800 seconds, which is again equal to 30 minutes. So half-life remains constant. So correct answer is option number A. For first order reaction, the half-life does not depend on the initial concentration. Now next one, which of the following is reduced with zinc and hydrochloric acid to give you a corresponding hydrocarbon? So you know zinc and HCl, that is your Clemmensen reduction. So ketones will react with that. So butanone is the correct answer to give you a hydrocarbon. So it will form butane. Okay. Now next one, 6.02 into 10 to the power of 20 molecules of urea are present in 100 ml of the solution. The concentration of the solution is. Very easy question. So first we can calculate the number of moles. Okay. So number of moles will be the total number of molecules divided by the Avogadro number. So we can have 6.02 into 10 to the power of 20 divided by 6.02 into 10 to the power of 23. So how much will get number of moles? 10 to the power of minus 3. Now if I want to calculate molarity, so that will be equal to number of moles by volume. So volume is 100 ml, okay, and then into 1000. So now if I see this one, we will get 10 to the power of minus 2, so 0.01. Correct answer for this question will be option number B. Now next one, pure benzene freezes at 5.3 degrees Celsius and a solution of 0.223 gram of phenyl acetic acid in 4.4 gram of benzene freezes at 4.47 degrees Celsius. From this observation, one can conclude that. Okay. So first of all, we can see what are the values given. So we have pure benzene. Okay. So the freezing point of pure benzene is your 5.3 degrees Celsius. And after adding the solute, the freezing point has become 4.47 degrees Celsius. Okay. Next, whatever is given, mass of the solvent. Okay. Mass of the solvent is 4.4 gram. And the mass of the solute is, we have been given 0.223 gram. 0.223 gram. Okay. Now, if you calculate the phenyl acetic acid, C6H5CH2OH, so its molar mass you will be getting around is 136 gram. Now, we can calculate here from the options. You can see that there must be some dimerization or some association or dissociation, right? The options are in such way. So, we can write delta TF is equal to I into Kf into M. Okay. So now let us first calculate the molality separately. Molality will be equal to given mass, that is 0.223 by molar mass into 1000 by mass of the solvent. Okay. So now if you solve this, you'll be getting around 0.37. The values will be somewhere around here. Now if you calculate this value, delta TF, okay, delta TF will be equal to 0.83, right? So we will get, we'll get 0.83. So now I can calculate I value will be equal to delta TF by Kf into M. Now delta TF value is 0.83, okay, and Kf value, if you see, that is also mentioned to you, 5.12, and molality is around 0.37. Okay, so now if you solve this, you'll be getting around 0.4 something. So the I value is less than 1. So we know that if I value is greater than 1, it is dissociation. If I value is less than 1, it is association. So now first, phenyl acetic acid exists as such in benzene, it will be not there, otherwise the I value would have come to 1. Next, phenyl acetic acid undergoes partial ionization. There will be no ionization or dissociation, rather it will be association. So complete ionization is also incorrect. Phenyl acetic acid undergoes dimerization in the benzene. So here this option shows about association. So now if you solve the alpha I minus 1, then you may get that it is undergoing dimerization. But from the options, you can clearly say that association has to happen. And in option D only association is given. So correct answer for this question will be option number D. Okay. Next question. The time taken for 10% completion of a first order reaction is 20 minutes. Then for 19% completion, the reaction will take, okay, very simple question. We have this formula, T is equal to 2.303 by K log of, so first one is 10% completed, so remaining will be 90, and the next value is, this value is 20 minutes, right? So T1 is 20 minutes. So I'll substitute directly. Here we will get 20 minutes. And then the time is asked for 19%. So 2.303 by K log of 100 by 19 means 81. 19% is completed means 100 by 81 is left. Now just take the ratio of this by this. So T by 20. Okay. If you take T by 20, this all will get cancelled and I am left with log 100 by 81. Can it be written as log of 10 by 9 its square, right? So I'll write log 10 by 9 square and whole divided by log of, here also I'll get 10 by 9, right? So now this 2 can come here. So T by 20 is equal to 2. So that means T is equal to 40. So the correct answer for this question will be option number A. Next one, the titanium compound that does not exist is. So what is the electronic configuration of titanium? 4s2 3d2. Maximum valency or oxidation state it can show is +4. Now here it is +2, here it is +4, here it is +3. But if you see here, 2 plus x minus 8 is equal to 0, x is equal to +6. So titanium here is showing +6 oxidation state, which is not possible. That is why this molecule will not exist. Correct answer will be option number D. Next, the electrode potential of Cu2 plus to Cu plus, Cu plus to Cu are given. You have to calculate for Cu2 plus to Cu. So you can do this question easily using your Latimer diagram. Cu2 plus to Cu plus and Cu plus to Cu. Now this value is given to you as 0.15 volt, okay, and this value Cu plus to this value is given as 0.5 volt. Now if you see here, this value we have to calculate. So our formula is N1E1, okay, N2E2 and N3E3. So what is the formula here? N3E3 is equal to N1E1 plus N2E2. Now here the number of electrons +2 to +1 is 1. E1 value is 0.15 volt. Similarly, here it is 0.5 volt. Then if I add this, and what is the value of N3? Here +2 to 0. So +2 to 0, so value is 2E3. So that is equal to 0.65. Now if you calculate E3 value, it will be 0.65 by 2. So that is equal to 0.325. Okay. So the correct answer for this question will be option number C. Next, on heating with soda lime, the salicylic acid gives. So if you have salicylic acid, this is the structure, right? So when you heat it, this one will undergo decarboxylation and we are left with only phenol. So correct answer for this question will be option number A. Next, this is important question again. Red hot carbon will remove oxygen from the oxide AO and BO but not MO. Okay, this is MO. So there are three oxides, MO, BO and MO. Okay. Now red hot carbon can remove oxygen from these two, right? Means it can reduce, a removal of oxygen is what? Reducing. So it can remove carbon, carbon can reduce A and B but not M. So definitely M is a better reducing agent than carbon. Now let us read the next statement. While B will remove oxygen from AO. So B can reduce AO, right? That means B is a better reducing agent than A. So we will get B and then A. Now the reducing power is similar to the reactivity order. So the reactivity order is M is greater than B greater than A. So correct answer for this question will be option number C. Okay, next question. Which of the following is the strongest base among the following? So if you know, once we go along the period in lanthanide series, what happens? Lanthanide contraction takes place, size becomes smaller, the effective nuclear charge increases, so the tendency to donate electrons will decrease. And what is the definition of basicity? Basicity is defined as the tendency to donate electrons. So along a period, the basicity will increase. So lanthanum is the first element and lutetium is the last one. So here the basicity will be highest. So the correct answer for this question is option number A. So these were the first 30 questions of your mock test 3 chemistry solutions. So I hope you have all solved the questions. If you have any doubt in any question, so please comment down. I'll definitely address it. And if you have found this video helpful, please like, share and subscribe our channel. Thank you.